Hey guys, this is Miss Samra. I'm back with my next lesson and 9-2. Still, we are learning about sequences, and today's focus will be on arithmetic sequence, which you guys already learned a little about that on Friday. So it's 9-2. It's arithmetic sequence. So first, I'm actually going to practice a few on how to identify, even though we did it on Friday, but just to give you more practice. So let's say I have 15, 12, 9, 6, and dot, dot, dot. Another one, I have 1, 4, 9, 16, 25, and dot, dot, dot. All right, how do we check if it's arithmetic or not? First thing you need to do is you need to find the difference. So finding difference, and for difference, the symbol is lowercase letter d. Okay, how do we find the difference? Here's the shortcut. I know you can just look at the numbers, you can figure that out. But like, let's say you have fractions or you have negative numbers. It's not that simple to find the difference. Here's the shortcut you could do. In order to find the difference, you could always take a second term minus the first term. That's how we find the difference. Or you can pick any two numbers and then just take the preceding term, take away the term before. That's how we find the difference. But don't forget, in order to be arithmetic, the difference has to be same for every single numbers, okay? So this one here, 12 minus 15. Let me pick a different color. So 12 minus 15 is negative 3. Let's check with next two. 9 minus 12, another negative 3. 6 minus 9, which is negative 3. So it means if it's the same difference, it's definitely arithmetic sequence. Let's try same strategy with the second one. 4 minus 1, 3. 9 minus 4, 5. 16 minus 9, 7. 25 minus 9 is 9. We have difference every time. So it means it's not arithmetic sequence. Okay. So that was kind of like a review from Friday's lesson. So now let's move on to next step. So it's 9-2 and I'm on page number 697. If you want to practice one like this, you can still practice got it one problem, A and B both. And I hope that would help. Okay, next one. So next, let's say I have a sequence like 15, 12, 9, 6, dot, dot, dot. And if I ask you for A 200. First of all, I hope you understand my question. I'm asking you for the 200th term in this sequence. So do you really think you're going to spend 15 to 20 minutes going by this pattern and finding 200th term? No, I'm not doing it. No, trust me, I'm not doing it. It's like a lot of effort, a lot of math for sure, yeah. But I'm not ready to do that. So what I'm going to do is, I have a different way to deal with something like this. Anytime you're solving for a term which is farther than the numbers we know, there's another way. There's a shortcut. There's an easier way to solve for that missing term. So how do we find missing term of a sequence? So normally we have two different ways. In order to find missing term, you could do explicit rule. And another way is recursive rule. But today's lesson is totally focused on explicit rule. How do we do explicit rule? There's an equation you need to use. That's a formula. You just have to plug everything in and we solve for the missing term. But you know what? Every time, even though we do it in class, I don't give you the equation right away. I love to explain the logic first and then we'll figure out the equation and then we'll plug everything in, right? All right, stay strong. We need to learn the logic first, okay? All right, so let's try understanding the logic for explicit rule. I'm just going to start off with the easy sequence. Let's say my sequence is 3, 5, 7, 9, and dot, dot, dot. I'll make a table just to show you the pattern. So I'm just going to draw 4 different columns here. So let's say my first term, which is 3, so yeah, it would be 3, and I'm just going to say, yeah, still my first term. For second term, I know if I look at the sequence, it's 5. But isn't it, I could also say it's my first term, which is 3. And if I just add the difference, which is 5 minus 3, if I add the difference, which is 2. Does that make sense? Isn't it the same thing, right? Okay, let's say my third term. I know by looking at this sequence, I know it's 7. Let's just follow this pattern here for this column. So let's just say if I take this whole expression, which is 3 plus 2, and add another difference to that, which makes 7 still, isn't it? Right? Let's look at the next term, which I already know it's 9. But how about if I take all these, which is 3 plus 2 plus 2, and add another difference to that, isn't it? Now let's try discovering this pattern. So my first term, yeah, for the first term, it would stay the same. My second term, so this first term stays the same in every single term. But what's different is number of differences in there. So my second term still has this first term in it, along with one difference. Okay, now let's look at the third term. Again, it has a 1 in it, but how many differences do you see? I see 2 differences. Okay, for the fourth term, again, I see my first term, which is a 1, but how many differences? I see 3 differences. So next, if I ask you for the 10th term, you know what's going to happen. A1's definitely going to be there, for sure. But how many differences you need? I need 9 differences to get my 10th term. I hope you understand the pattern. And that's what explicit rule is. Now let's try understanding. So again, if I ask you for 200th term, now you know it's definitely going to be your first term for sure. But how many differences? I need 199 differences to find this term. All right, now let's write down the equation for the nth term, because you know it's not going to be 200th term all the time, right? So let's just say what's going to be my explicit rule. So let's say if I'm solving for my nth term, yeah, A1, which is my first term, would stay the same. This expression, where does this expression come from? This expression is 1 less than the term you're solving for. So I'm just going to say n minus 1, and here's the difference. Here you go. And that's what explicit rule is, okay? Now, if I use, okay, let me just use a different example, and then we'll solve for the term we are solving for. Let's say I have a sequence, which is 6, then I have 11, then I have 16, then I have 21, ... And my question to you guys is to find me 165th term, okay? What I need is, as per this explicit rule, I have to have my first term, which is 6. All right, now I need n minus 1 differences. If I'm solving for 165, it means I need 164 here. 164 differences. And what is the difference here? So let's find the difference. 11 minus 6, 16 minus 11, 21 minus 16. What's the difference every time? It's 5. So difference is 5. Now rest is pretty much solving everything. So let's solve. I have 6, 164 times it by 5, and it's 820. And if I add 820 to 6, it's 826. And that's my 165th term. You can even check if you want it. Trust me. And that's how we do explicit rule. Okay, so that was my first example. If you want to try one like this, you can try. Got it? problem number 2, got it 2 on page number 697. And for part A, answer is 93 if you want to check. So you can try first, and the answer is, I'm giving you the answer right away so that you can check if you're doing right or not. Okay?